Welcome to the fourth session, that is how to measure or measurements of vertical angles. Till now we have seen two methods to calculate the horizontal angle. It's not a method, it is a same method but different types of horizontal angles, right? Now we are going to study how to read or how to observe the vertical angles now, right? So before we go into, we have seen the experiments, we know how to observe. Now, one thing before I go to the vertical angles, we have to observe the readings not in the horizontal circle. We have to observe the reading in the vertical circle, which is of 90 degrees. Okay, which is 90 degrees, right? Which has 90 degrees. 90 degrees up, 90 degrees below. That is total 180 degrees. So here we have vernier C and D. We don't have vernier A and B. There it was 360 degrees total, divided into 180 by 180 and 180 this side. So here it is total 180, right? And the half is 90 degrees, which is above, and which is below. That is D, C and D. There are two verniers of 90 degrees apart each other, right? So that is a difference, and we are going to measure the angle from the horizontal circle. Here also two readings, face left and face right observations. So that is one thing you have to understand. We have talked about this in the while we are observing the readings, right? So once before we start with the explanation, we'll go through the procedure first. How to do the how to measure the vertical angle. So set up the instrument over a station A, right? First one, set up the instrument over a station A and do all the temporary adjustments and keep the vertical circle to the left. Leveling of the theodolite is done by using altitude bubble. The operation involved are as same as of leveling using plate level. So here we are not going to take the level tube of the horizontal circle. We are going to take the altitude bubble which we have seen where it is, okay, same operation to parallel to the 2 foot screws and again perpendicular to the 1 foot screw. So same operation will remain same. We are going to refer the altitude bubble there, right? Now you have to see that the angle reads 0. Where will be 0? If I show you, right, if I show you, don't go to this diagram, we'll see it later. It is like this, right? Here it is 0, here it is 90, here it is 90, right? This is vernier C, vernier D, right? To observe the reading, your telescope should be at 0 degrees first, like this, right? From there we have to again shift it upwards or downwards depending upon the inclination or declination it is called, right? So depending upon which point you have to find out the angle, vertical angle. These are the two types of vertical angles. It is inclination angle, one is declination angle. So these are the two angles in the vertical angle, right? So upon first we have to bring it to the 0, right? So loosen the vertical clamp. Now here you are not going to use the upper clamp and the lower clamps of the horizontal circle. There is a clamp which is used in the vertical circle. Near the telescope it is there. At the side of the telescope there is a clamp, right, which is used for the horizontal deviation of the telescope, right? So that clamp you are going to use and bring the telescope such a way that it is making 0 0 with the vernier C and D should be 90 90, right? At the center where you're going to read it should be 0, right? At the top it approximately along the C and D vernier it would be automatically 90 degrees at both the sides, right? It is from the center, it is 0 to 90 at top, and from the center 0 to 90 at the bottom, as I've shown in the previous figure, right? You have to see that it reads 0 0, that it means it is along the axis of the telescope or the line of collimation. It is along the line of axis, right? Now once it is level 0, then tighten the vertical clamp. Tighten the vertical clamp. Okay? If you allow it, it will again move. So you want the fixed angle to be 0, right? Then bisect the point, or then slowly loosen the vertical clamp and bisect the point where of which you want to find the angle with respect to that 0 degree. I will show you, don't worry, with the reference line. Okay, we'll see that. Just understand now what is trying to say. Bisect the point of which we want to have a vertical angle with the help of the vertical tangent screw for get the vertical readings. Record the scale with the vernier C and D in the form of tabular. Change the phase, read the vertical reading again, and you have to do this 3 times, total 3 times, to get an average, so that there is no, if there are any errors in the while reading the readings or in the instrument, that is to be rectified. So for that, what we do is we take the 3 trials of same angle, right? Same reading we are going to take 3 times, and we will get the average of it, and we are going to say that that is an angle, average angle, that is your vertical angle, you want to say. So that is what is your procedure to measure the vertical angle, right? There is a difference that we are going to use vertical circle here, not the horizontal circle. Right, this is your building here. This is a building whose top is to be bisected, and you have to find the angle, right? You have to find the angle. So what you're going to do is, this is your normal axis. When you make your telescope 0 to 0 at the vertical circle, this is your reference line from which you are going to find out the angle. Now it is at the start, you have to loosen the vertical clamp, bring it to the 0, set up the vernier, and close the vertical clamp. Now once you have done it to be 0, then loosen the vertical clamp slowly and bisect the point where of which we want the vertical angle, with reference to what? Angle is reference to this line, not from the ground. From this line of axis, you are going to measure this angle, right? Whatever angle you get once you bisect this point, then tighten the clamp. Once you bisected this point, tighten the clamp, and whatever the angle you are getting is with respect to what? This line of axis. With the line of axis, this is an vertical angle. That is, you will get the vernier scale C and D angle, or vernier C is mostly enough when you are finding the inclined angle, right? That is upward angle, this angle, right? When you bisect it downwards at the bottom of the building, it is called deflecting angle or declination angle. It is called inclination angle, it is called as declination angle. So that time you are going to, when you read at the bottom below the 0 degree, it is, you are going to read D vernier. When you are reading the above the leveling axis inclination angle, then you are going to use vernier C. That is the difference here. Both will give you same reading, no problem. If you don't read, you read D or C, that doesn't matter, but you have to see that it is opposite, right? Whatever angle you get, you have to divide it by 180, so you will get the angle. So that is what, how you calculate the vertical angle. Understood? 2 ways you can calculate the angle. It might be at the bottom of this ground, or at the top of the ground, and top of the building. So whatever angle, vertical angle you want, you can calculate in this. In the same way, you have to turn the telescope like this upwards to get the upward angle. If you get it downwards, you will get a downward angle. So this is how you calculate the vertical angle. You don't have too much of screws in, sorry, you don't have much of screws here. You have only two screws. It is vertical clamp and vertical tangent screw. These are the only two screws, and it is very easy, right? That's all. This is how you calculate the vertical angle.